Okay, we're going to start this lesson off. It is about vectors, so for some of you this is going to be totally new. A vector is a directed line segment with magnitude, so it has direction and magnitude, which can be the length. When you're writing a vector, you write it as just like you would a ray, PQ, your initial point P and your terminal point Q. The magnitude is the distance, and the direction of the vector is its slope, your rise over your run. Two vectors are equivalent if they have the same direction and magnitude. That's very important. They have to have the same direction and magnitude, exactly the same to be equivalent. Okay, let's see if U and V are equivalent. U is going to be represented by the line segment from 0, 0 to 3, 2. So I'm going to call this my y-axis. This is my x-axis. So it starts from P, which is at 0, 0, and goes to 3, 2. So this is Q. Beginning and ending, very important where your arrow is pointing. V, on the other hand, starts at 1, 2. Starts at 1, 2. And that's R, and goes to 4, 4. So 2 there. There's S. Show that U equals V. The way we show it, they have to have the exact same magnitude and slope. So if I look at magnitude now, if I want the magnitude of vector PQ, I'm really wanting the distance. You can think of the distance as, if I'm looking at PQ, if you look at it as a right triangle, you're really solving for the hypotenuse. So it's going to be the square root of my two legs squared, added together, 3 squared plus 2 squared. 9 and 4 is 13, so this is the square root of 13. Then if I go for the magnitude of vector RS, then I have the square root of, if I look at its triangle, 1, 2, 3, and 2. So 3 squared plus 2 squared, so the same answer, square root 13. So we're good there. And then I need to look at their slope. Slope, remember, y2 minus y1 over x2 minus x1. So for PQ, this would be 2 minus 0 over 3 minus 0, so 2/3. For RS, this would be 4 minus 2 over 4 minus 1, which is 2 over 3. Exact same thing. So we have shown that U is equal to V. The component form of a vector is essentially its slope. How did I get, we're going to call the beginning point 0, 0, and how did I get to the ending point? I went left and right this far, and up and down this far, so I guess it's the reciprocal of slope. Find the component form and magnitude of vector V that has initial point 4, negative 7 and terminal point negative 1, 5. So let's see, we need Y to go from negative 7 to 5. I don't know if we'll make it on this. So if we extend it down a little bit, we can get to 5 and negative 7. On the x-axis, I only need to go to 4 and negative 1. Okay, so my initial point is 4, negative 7, 4 down 7. So there's my initial point. My terminal point is negative 1, 5. So my vector...
Good afternoon, everyone.
So here's my vector starting at my initial point going to my terminal point. And your component form is essentially, how did I get from the initial point to the terminal point? Well, I had to go left 5 and up 12. So left 5 would be negative 5, up 12 would be positive 12. To find the magnitude, that's the distance. Negative 5 and 12 are the two legs of my triangle, so 5 squared plus 12 squared. Take the square root of that. It's going to be the square root of 169, which comes out to an even 13.